I teach maths and French, and from now on, we'll be conducting some online classes in mathematics. Welcome. Now, today we'll do a lesson in statistics, Form 4. And from basics in Form 2, we learned 3 statistical measures, which were discussed as the mean, the mode, and the median. These are generally known as measures of central tendency. In Form 4, we're going to learn how to get the mean using a working or assumed mean. For example, look at the 3 sets of data given below. There's data A, which has 2, 5, 10, 12, and 16. There's data B, which is gotten from data A by adding 5. So 2 plus 5 is 7, 5 plus 5 is 10, 10 plus 5 is 15, 12 plus 5 is 17, then 16 plus 5 is 21. That's data B. Data C is also gotten from data A by subtracting 1. So 2 minus 1 is 1, 5 minus 1 is 4, 10 minus 1 is 9, 12 minus 1 is 11, 16 minus 1 is 15. Now, if we were to get the mean of data A, normally we just add all the numbers. That's 2 plus 5 plus 10 plus 12 plus 16. Then we divide by 5. That gives us 45 over 5, which is 9. So the mean for data A is 9. Mean for data B is 7 plus 10 plus 15 plus 17 plus 21, which gives us 70. Then 70 divided by 5, which is 14. You'll notice that the mean for data A was 9, and by adding a value of 5 to every digit in data B, we obtain a mean of 14, which is basically 9 plus 5. The mean for data A plus the addition or whatever we added, the constant that we added, that makes it 14. So the mean for data B is 14, which is 9 plus 5. Data C, we subtracted 1. So the mean for data C, we can notice, is 8, which is basically 9 minus the 1 that we subtracted. That gives us a mean of 8. So what do we learn? We learn that by increasing every k, by adding k or subtracting k from each figure in a set of data, the new mean of the data obtained is by adding or subtracting the k, the same constant that you added or subtracted. So if I give you data with a mean of, say, 10, give you a data with a mean of 10, then you add 5 to every digit, then our new mean is going to be 15. Our new mean is going to be 15. Let's look at example 1. The earnings per day of a group of 10 hawkers are stated below. So approximately, the first hawker gets 530, 550, 560, 570, 590, 600, 610, 620, and so on. There are 10 of them. So if we put the data, the earnings, we call them X. That is our first column, 530, 550, 560, 570, all the way to 650. Then we subtract a constant from that mean, preferably a number that's in between 530 and 650. And the number I preferred in this case is 590. You're free to use any other number, but I prefer to use 590. So I'll take my data, which is 530, and so on. Then I get deviations. What I'm calling D are deviations from the X. So X minus A minus 590 is my assumed mean. I'm assuming 590 is my assumed mean. So I'll take 530 minus 590. That will give us a difference of 60. 550 minus 590, negative 40. 560 minus 590, negative 30. 570 minus 590, negative 20. 590 minus 590, 0, and so on. When you add all these deviations, that's what I'm calling summation of the deviations. When you add the deviations, the negatives, you can see the negatives add up to negative 150. And the positives, this is 60, 110, 140, 160, 170. So 170 minus 150, that gives us 20. So when we get the mean of the deviations, that is 20 divided by the number. There are 10 of them. These numbers are 10. That's what I'm getting here, 20 divided by 10. 20 mean being the summation of the deviations, then divide by the number, which is 10, we obtain the mean for the deviations as 2. So to get the actual mean for the data, we just take 590 plus those deviations. So 590 plus 2. And that gives us a mean of 592. We note that if we are to add all these numbers manually, it would be cumbersome. So using an assumed mean makes our work easier. That is why it's good to use an assumed mean for big data. We move to example 2. Example 2 is different, slightly different from example 1, because in example 2, we have, for example, the masses to the nearest kilogram of 20 students were recorded below. So you have the mass, the first student, the first 2 students have a mass of 50. The next 4 students have a mass of 53. The next 6 students have a mass of 56. The next ones have a mass of 60. And the last ones have a mass of 62. So when you add all these, they should give us 20 students. So 2 plus 4, 6. 6 plus 6, 12. 12 plus 5, 17. 17 plus 3, 20. That's the number of students. So we need to get the mean of these students using an assumed mean. And in this case, you are requested to use an assumed mean of 56. So our simple task is to arrange this data in a table. So the table will have the first column as being the mass, and the mass is 50 kg, followed by 53 kg, 56 kg, 60, and 62. This is our first column, becomes our first row, becomes our first column. That's what I'm calling X. Next, we need the deviations from the assumed mean. The assumed mean is given as 56. So the deviations will take X minus 56. For example, in the first one, we'll take 50 minus 56. 50 minus 56, we get negative 6. Next one is 53 minus 56. 53 minus 56 gives us negative 3. The next one is 56 minus 56. That gives us 0. The next one is 60 minus 56. That gives us 4. And the last group is 62 minus 56. Note that the 56 is assumed mean. So you take X, the mass, the actual mass, minus the assumed mean. And we call those the deviations from the assumed mean. So these are the deviations from the assumed mean. But in this second example, the first deviation has a frequency of 2. So there are 2 students with that deviation. So we'll take negative 6 times 2 to get us frequency times the deviations, which is negative 12. The next one will take negative 3 times 4, and that gives us negative 12. The next one will have 0 times 6, that gives us 0. Then 4 times 5 gives us 20. And the last one is 6 times 3, it gives us 18. When you add all these deviations, negative 12 plus negative 12 plus 20 plus 18, we are going to obtain the summation for the deviations as 14. So after that, we get the mean of those deviations. So the mean of FD, which is summation of FD, which is 40 over the frequency. 14 divided by the frequency, which is 20. So we obtain 14 divided by 20 is 0.7. So to get the actual mean, we'll take the assumed mean plus 0.7, the mean of the deviations. So the assumed mean is 56 plus the mean of the deviations, which is 0.7. That gives us 56.7. Hope it's understood. Thank you. We'll move to example 3. So note the difference between example 1 and example 2. Example 1, the frequency is 1. Frequency is 1 throughout. So look at example 2. 50 has a frequency of 2. 53 has a frequency of 4. 56 has a frequency of 6. 60 has a frequency of 5. 62 has a frequency of 3. That makes us have an extra column so that we have the frequency times the deviations. We move to example 3. Example 3 is group data. Group data, we learned the necessity of grouping data. So for group data, for example, in the example given, the following table shows the distribution of marks obtained by 50 students in a certain secondary school. So the marks as on the table, 45 to 49, we had 3 students. Between 50 to 54%, we had 9 students. Between 55 to 59%, we had 13 students. Between 60 to 64%, we had 15 students. Between 65 to 69%, we had 5 students. Then between 70 to 74%, we had 5 students. When we add all these students, 3 plus 9, 12, 12 plus 13, 25, 25 plus 15, 40, 40 plus 5, 45, 45 plus 5, 50. So there are a total of 50 students. Now we are requested to use a working mean of 62 to obtain the actual mean. So we are going to do another table. First column is going to have the marks as it is, 45 to 49, 50 to 54, all the way to 70 to 74. Then because the groups are, it's a grouped data, we need to get the midpoints. How do we get the midpoints? We just add 45 plus 49 divided by 2. 45 plus 49 divided by 2. Those are the midpoints, 47. The next one is 50 plus 54 divided by 2. That gives us 52. The next one is 55 plus 59 divided by 2. That gives us 57. Then 60 plus 64 divided by 2, 62, and so on. So to get the midpoints, just add the 2 and then divide by 2. Next, we need the deviations from 62, our assumed mean. So deviations from the midpoint, which I'm calling x, minus the assumed mean. So in the first case is x 47 minus 62. That is, I get 15. 47 minus 62, I get negative 15. The next one is 52 minus 62. 52 minus 62, that gives us negative 10. The next one is 57 minus 62, that gives us negative 5. The next one is 62 minus 62, that gives us 0. The next one is 67 minus 62, that gives us 5. And the last one is 72 minus 62, that gives us 10. Once we have the deviations, then in this case we have frequency. Just like the previous case, we have the frequency. So we register the frequencies as our fourth column. So frequencies 45 to 49 is 3, followed by 9, followed by 13, followed by 15, followed by 5, and then lastly we have 5. After that, we multiply the frequencies times the deviations from the assumed mean. So FD, our next column. So that's negative 15 times 3 gives us negative 45, negative 10 times 9, negative 90, negative 5 times 13, negative 65, 0 times 15 is 0, 5 times 5, 25, 10 times 5, 50. After that, we add those deviations. So adding this column up, we'll get negative 125. So we get the mean of these deviations. So mean of the deviations is negative 125 over the number of students. So negative 125 divided by 50. That gives us negative 2.5. So to get the actual mean, we'll take the assumed mean plus negative 2.5, which is the mean of the FD. So that will be 62 plus negative 2.5, which gives us a mean of 59.5. Now, we can go ahead to make the process easier. When you are faced with big numbers, sometimes it's good to make work easier. So same data, 45 to 49, the midpoint was 47, 50 to 54, the midpoint was 52. 55 to 59, the midpoint was 57. 60 to 62, midpoint is 62. 65 to 69, the midpoint is 67. Finally, 70 to 74, the midpoint is 72. Still using the same assumed mean. So 47 minus 62, negative 15. 52 minus 62, negative 10. 57 minus 62, negative 5. 62 minus 62, 0. 67 minus 62, 5. And finally, 72 minus 62 is 10. What we notice is that in this column, we have negative 15, negative 10, negative 5, 0, 5, and 10. All these numbers are divisible by 5. So we can make our work easier by dividing them by 5. It's easier to work with a 3 than a 15. So by dividing by 5, so I'll get this negative 15 divided by 5, I'll get negative 3. Negative 10 divided by 5, I'll get negative 2. Negative 5 divided by 5, I'll get negative 1. 0 divided by 5, I'll get 0. 5 divided by 5, I'll get 1. 10 divided by 5, I'll get 2. After that, we multiply by the frequency. The frequencies were 3, 9, 13, 15, 5, and 5. So this times this, negative 9, negative 2 times 9, negative 18, negative 1 times 13, negative 13, 0 times 15, 0, 1 times 5, 5, finally 2 times 5, 10. Then we do the same, add the FT together. So by adding these, we'll get negative 25. Now there's a catch here. We divided the deviations by 5. So the formula is going to slightly change. When you divide the deviations by 5, then this part of the equation, you'll take the assumed mean, normal. Then this part where we have negative 25 over 50, we must multiply by 5 before adding to the assumed mean. So 62 plus, this will be negative 125 over 50, which is negative 2.5, will give us an assumed mean, will give us an actual mean of 59.5. We note that by dividing by 5 all through, by a convenient number and convenient constant, we've made our working easier. The numbers are smaller and more manageable. That is why we need to divide by a constant to make the numbers more manageable and smaller. A second process of making our working easier, if you have large numbers, for example, populations of countries, if you're told to get the population of Africa, for example, those are millions and millions of people. I've given a small example of salaries. For example, the salaries to the nearest 1,000 shillings of 10 workers in a certain company are recorded below. So you have the salary. Between 20 to 24,000 shillings per month, we have one worker. Between 25 to 29,000, we have 3 workers. Between 30,000 to 34,000 shillings, we have 4 workers. Between 35,000 to 39,000, we have 1 worker. And then between 40,000 to 44,000, we have 1 worker. These are large numbers. These are large numbers. So if we write the salary as 20,000 to 24,000 as our first column, 25,000 to 29,000, 30,000 to 34,000, 35,000 to 39,000, 40,000 to 44,000. Our midpoints, as usual, we are going to add these 2 and then divide by 2. Add these 2, divide by 2, add these 2, divide by 2, same. So our midpoints are 22,000, 27,000, 32,000, 37,000, 42,000. These are large numbers. So to make it easier, we can divide by a constant. In this case, our constant is 1,000. It can be any constant. So I've decided to divide by 1,000 to get rid of the zeros. So this will be 22,000 divided by 1,000, that's 22, 27, 32, 37, 42. Then we'll choose an appropriate assumed mean. From here, I've chosen preferably the middle one. So 22 minus 32, negative 10. 27 minus 32, negative 5. 32 minus 32 is 0. 37 minus 32 is 5. 42 minus 32 is 10. Then we multiply by the number of workers. So negative 10 times 1, negative 10. Negative 5 times 3, negative 15. 0 times 4 is 0. 5 times 1 is 5. 10 times 1 is 10. When you add all that, we'll get the summation for those deviations is negative 10. Now, to make our work easier, to get the mean, we'll just do the same normal way, assumed mean, plus this column, negative 10, over the frequency. This is our frequency, the number of workers. Then after that, big bracket, we are going to multiply by the constant. Okay, the 1,000 that we divided by. That has made us avoid the big numbers, the zeros, to make our work easier. In this way, we are able to calculate mean populations of countries and any big numbers that require us to use an assumed mean. Thank you. That will be our lesson today. See you tomorrow.